This is Professor Pelton. This is Trigonometry, Chapter 1, Section 5. This is Part 3 of the video. So now we want to evaluate trig functions for any angle, positive, negative, degrees, radians, acute, obtuse, more than 360, more than 2 pi, whatever the case may be. So we need to use our skills from before, which is using our odd and even function things and our reference angle skills. So first you want to determine the reference angle, evaluate the trig function of the reference angle, and then we need to appropriate what quadrant is it actually ending up in, the original angle, not the reference angle, the original angle. Where does it end up? Okay, and then you have to decide on, is it positive or negative, okay, in that quadrant. Okay. Right. So basically, whatever it is, figure out the reference angle, evaluate it, and then decide on negatives or positives depending on where it ends up. So first off, we need to know your unit circle. So I would go back and review your unit circle and watch the video if you still do not have sufficient skills on the unit circle. Because all you need to know is the first quadrant. So if I do the first quadrant of the unit circle, we get a coordinate of 1, 0. We get a coordinate of 0, 1. And we can connect them with our partial circle, and we can make the coordinates in between the special ones. There are infinite numbers in between, but there are 3 special ones that we do. So first is the 45 degrees, otherwise known as pi over 4 radians, which is the root 2 over 2, comma root 2 over 2, which is our cosine and sine values. So sine is root 2 over 2, cosine is root 2 over 2, tangent is sine over cosine, which is root 2 over 2 over root 2 over 2, thus 1. And then we have the 30 degrees, otherwise known as pi over 6, 1/6 of pi, right? Pi over 6, which is the 1/2. I'm sorry, that's backwards. I'm thinking of the wrong one here. Root 3 over 2, comma 1/2. So that means the sine is 1/2. The cosine is root 3 over 2. So we have 1/2 over root 3 over 2, which is 1 over root 3 for tangent. And lastly, the 60 degrees is 1/2 comma root 3 over 2 for our pi over 3, 1/3 of pi. Okay, so that means that our sine is root 3 over 2, our cosine is 1/2, so tangent is root 3 over 2 over 1/2, which is root 3 over 1. And you might notice that these don't exactly match up the unit circle, because they tend to rationalize this one on the left. They'll rationalize it, and they'll get the root 3 over root 9, which is root 3 over 3. This is sufficient, but that's what they show on the unit circle. And those are all come about with the special right triangles, of course, when we did the unit circle. But as we saw in this lesson, the quadrantals don't make triangles, and some of them are undefined. Thus, you have to use the formal definitions of the functions to get the values. So if the radius is 1 and that coordinate is 1, 0, we have cosine, sine, so sine over sine and cosine. Sine over cosine gives us 0. So at 90 degrees, I have 0, 1, which is our sine and cosine, and sine over cosine is undefined for tangent. At 180 degrees, I have negative 1, 0, which is sine and cosine, and sine over cosine gives us 0 for tangent. And lastly, at 270 degrees, I have 0, negative 1, which is our sine over cosine. Sine over cosine is tangent, which is undefined. All right, so knowing these two tables is pertinent to being able to evaluate trig functions quickly and effectively. Okay, we do not want the rounded decimal answers. We want the actual ratio of the sides to be able to solve trig problems. Okay, so let's use our trig rules here to evaluate these functions that are more than an acute angle. That's the other quadrants. So if I do sine of 135 degrees, that is the same as doing the sine of the reference angle. So the reference angle is going to be 45 degrees to add up to 180 if I went out halfway around. So that's the same as 45 degrees. Then you have to ask yourself the question, I'm in the second quadrant from the original angle, which is the negative positive quadrant. Well, sine is positive in that quadrant, so therefore this answer is also positive. And the 45 degree value of sine is root 2 over 2. Excuse me. So if I do 4 pi over 3, that's the same as doing the cosine of the reference angle, which is pi over 3. Because I went 1 pi plus another reference angle of another third. That's kind of sloppy. Let me fix that. I went another third of a pi, right? So 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. Oh, I'm not making very good threes today. I don't know why. Okay, there we go. So this is the negative quadrant, which means both cosine and sine are negative, which means the outcome here is negative. Okay? And if you think about what the coordinate would be here, that is a coordinate for 60 degrees, correct? 1/3 of pi, which is the 1/2 root 3 over 2 coordinate. So that means cosine is a half. So my answer is negative 1/2 when I evaluate for the negative being in the third quadrant. All right, next one, cotangent of pi over 3. Well, that's going to be the same as the cotangent of pi over 3. Okay, but that is going to be in the fourth quadrant, which is the positive negative quadrant, correct? And we know that cotangent, its identity is cosine over sine. Okay, therefore, when I do cosine over sine, I'm going to get a negative answer for that quadrant. Also, this is an odd function, so the negative can just go outside anyways. I can turn it the other way. Because remember, cosine and secant are even functions. You can just get rid of the negative. Cotangent and all other functions that aren't so basically anything that's not cosine or secant is odd functions. The negatives can just come out if you want to. Okay, so that is also a 60 degree angle, which is the 1/2 root 3 over 2. Okay, so all we have to do is negative cosine over sine. So I get a negative 1 over root 3 answer. Okay, pause the video, try the student problems for yourself. Okay, so sine of 300 is going to be the same as doing the sine of the reference angle. Well, I think that's 60 degrees, isn't it? Because if I think about it, I went almost all the way around, which is 360. I have a reference angle left over of 60 degrees, don't I? So I don't really need to draw the picture. What I need to know is it's in the fourth quadrant, right? I should know that 300 in my head is in the fourth quadrant, and that is the positive negative quadrant, which makes the sine a negative answer. So I need to do negative 60 degrees. Well, I know the 60 degree coordinate is 1/2 root 3 over 2, right? But that has to be negative since it's in the fourth quadrant, so it's a negative root 3 over 2 answer. Okay? Okay, so tangent of 5 pi over 4 is going to be the same as doing the tangent of pi over 4 is my reference angle. Well, how do I know that? Well, I went around pi plus 1/4 more, right? Because I went around pi plus a reference angle of another fourth. Okay, well, that's in the third quadrant, which is the negative quadrant. Tangent is sine over cosine, so if they're both negative, the outcome is a positive outcome. Okay. Well, I know the 45 degree angle, which is pi over 4, is a root 2 over 2, comma, root 2 over 2 coordinate. So when I do this, it's root 2 over 2 over root 2 over 2, which is simply just a 1 outcome, or 1 over 1 for the ratio of the sides. Okay, lastly, secant of pi over 6, negative, is the same as the secant of pi over 6 as my reference angle. So if I draw this, okay, I'm going to go negative pi over 6. That means I'm in this quadrant here, right? So I'm in quadrant 4. So the reference has to be positive, of course, even though the angle went negative. And I know this is the positive negative quadrant, okay? but cosine is positive in this quadrant, so the outcome is positive for this answer. Pi over 6 is a 30-degree angle. The 30-degree angle, if I do that, is 1/2. I'm sorry, that is incorrect. The 30-degree angle is root 3 over 2, comma, 1/2. Okay? So I get an answer of root 3. Oh, no, I do not, because I do not want cosine, right? I'm doing secant. The reciprocal of cosine is secant, so that's 2 over root 3. So again, let's go back. There's two ways to evaluate. I know this is positive. One, I know it's positive because it's in this quadrant, right? And this is the positive quadrant for cosine. The second way I know is secant as an even function. I can just get rid of the negative, basically, because it's an even function. So there's two ways to know. Okay, let's try the problems that are more than 360 degrees. Okay, so let's say I have tangent of 14 pi over 3. Well, 2 pi is all the way around, so 6 pi over 3 in terms of thirds is one time around. So 4 pi is 12 pi over 3. That's twice around. So if I take 14 pi over 3 and minus the 12 pi over 3, don't I get 2 pi over 3? Okay, so essentially what happened was I went around once for 2 pi, once more to make it 4 pi. Ooh, that's kind of sloppy. Let's change that to a blue, and then we'll erase that, because I kind of hit the line there. Okay, so I went around once for 2 pi, one more time for 4 pi, and another 2/3. So this is my reference angle, though. So this is the same as the tangent of 2 pi over 3. Okay, it's exactly the same, which will give us exactly the same answer as the tangent of pi over 3 to get us the remaining third to make it pi. But then we have to evaluate for the last part, is this positive or negative? Well, this is the negative positive quadrant, but since tangent is sine over cosine, the outcome here must be negative. Then we have to think, pi over 3 is 60 degrees. The 60-degree coordinate is 1/2 root 3 over 2, correct? So this is a negative sine over cosine, which is going to be a negative root 3 over 1 solution for the ratios of the sides based on the angle of 14 pi over 3. So you can see in the angles it's a two-step process when it's more than 360. So first get out the iterations of 360 or 2 pi, and then figure out the reference from there. So the next one, 17 pi over 4. So in this case, 2 pi, whoops, I don't need to make a ratio there, is the same in terms of fourths is the same as 8/4. So 4 pi is the same as 16/4. Correct? So that's 2 times around. So if I have negative 17 pi over 4, and I add to that the 16 pi over 4, I'm going to get a pi over 4 left over. Okay? Alright, so what does that mean? I went negative. I went around, I think on the outside here. I went around once. I went around one more time. Okay, and then I had another fourth left over for a negative pi over 4, right? Because there's a fourth left over. But I need my reference angle to be a fourth. Okay. All right. So my reference angle is going to be secant of pi over 4. Then I have to think to myself, this quadrant is the positive negative quadrant. What is secant in this quadrant? Well, secant is the same as cosine. Cosine's positive, so I think we're good there. Okay, so so we don't only need a positive. We don't need to worry about the negative because this cosine is positive in the fourth quadrant. So the coordinate is root 2 over 2, root 2 over 2, which is the coordinate for a 45-degree angle. So I can't just simply take the cosine answer and call it a day because it's not cosine, it's secant, which is the reciprocal of secant. Okay. Pause the video, try the student problem for yourself. Okay, so we have cosine of 17 pi over 6. So 2 pi is, in terms of sixths, 12 pi over 6. Okay, so 17 pi over 6 minus 12 pi over 6 gives me 5 pi over 6. So this is the same as the cosine of 5 pi over 6, which is not a reference angle, however. That just means if I have a quadrant here, let's get a different color. I went around once, right, 12 pi over 6, and then I went around a little bit more. Let's go back to blue. There we go. Then I went around another 5 pi over 6, right, which is right there. 5 pi over 6 for the blue. So I went around 12 pi over 6, which is 2 pi, and then 5 pi over 6, which means my reference angle is in here, which means I need one more 6 to get around to pi, because pi is halfway around, right? So this is the same as the cosine of pi over 6 is my reference angle, right? So my reference angle is pi over 6. But I have to think, positive or negative? Well, this quadrant is negative positive, right? Second quadrant. And this is the cosine, so my outcome must be negative. Then I have to think, pi over 6, that's a 30-degree coordinate, correct? The 30-degree coordinate is root 3 over 2 comma 1/2. So my cosine value is root 3 over 2, but I have to tag the negative onto it. Okay? All right. Okay, so basically figure out where it ends up. Use the reference angle, figure out the trig function, then add the negative on if need be. All right, so if I look at this one, 2 pi is, in terms of thirds, because it's thirds here, 6 pi over 3. So 4 pi is 12 pi over 3. So 6 pi is 18 pi over 3. I think that's as far as we need to go, because negative 22 pi over 3 plus 18 pi over 3 gives us negative 4 pi over 3. I believe I got that right. Let's check the math here. Yeah, because 2 more is 20. Yeah, okay. So basically, if we think about it, let's draw a coordinate here, or a quadrant, not a coordinate. What happened? I went around 6 pi in the negative direction. So I went around once, twice, 3 times. Then I went another 4/3. So that's a pi and a third, right? Because I went over to pi, and my reference angle is right here, right? So my reference angle is pi over 3, because I went around a pi plus a third more to get 4/3. So this is the same as the sine of pi over 3. Okay? Or we can do the incremental step. The incremental step would be the sine of negative 4 pi over 3, because that's the same terminal side, which is the same as the sine of pi over 3. Now I have to think, if I'm here, is the outcome positive or negative? Well, this is the negative positive quadrant, and sine is positive in that quadrant, correct? So I don't have to worry about negatives here, because I'm doing a sine in that quadrant, so it must be a positive outcome. Well, pi over 3 is a 60-degree angle, correct? The 60-degree angle gives us a coordinate of 1/2 root 3 over 2. So the answer is root 3 over 2 for the ratios of the sides. Okay? That is the end of part 3.